Hi guys, I wanted to talk today about linear equations. That's so far most of what we've done in terms of graphing so far, but I just want to kind of broaden it for us. So a linear equation is anything that when you graph it is going to make a line. Now you might think, well, duh, anytime you graph anything it's going to make a line, but specifically with linear equation, it makes a perfectly straight line. So things like this or this or this horizontal line or this vertical line, right? So when it's linear, it is perfectly straight like that. So these would be examples of linear. Examples of nonlinear things would be something like, let's say we had a graph that looked like this. All right, you might say that's a line, but in math, that is not a line. That is a curve, right? So these are lines. These are curves. Later, as you get onto trig, you're going to start graphing things that look like this, that go on forever and ever in both directions. Again, that is a curve. You might end up with something that looks like this, or this. These are all famous curves, but when we're talking about lines, even though this is, in sketching or something, you would call that a line. In math, we don't call those lines, we call them curves. So we're specifically looking for things that are straight lines. Right. There are a myriad of things that we can do with lines. They show up in our lives in a lot of different ways. So we'll see a lot of word problems that deal with them. So there are very practical things, things that arise in our everyday lives that deal with lines, things that have a constant growth. Like when I go to work, I get paid, $10 an hour. So for every hour that I work, my pay is my paycheck is gonna increase by $10. Right, so that would be something where there would be a constant growth rate. There would be maybe constant decline of some sort, or maybe zero growth. All right, so that would be something like this, where it just flatlines it. And so that is one thing that we'll notice about linear equations is a constant the growth rate or a constant decline or zero, but either way it's constant, whether it's increasing, decreasing, or zero. And again, we've got this funky case over here. Whereas with curves, it changes. All right, sometimes it grows, sometimes it decreases, and it might change again. Here, this is constantly growing, but here it's growing really fast, where here it's kind of growing slow. Same thing here. Here it's growing a lot faster. Here it kind of levels out. Here it's decreasing. Here it's increasing. So linear equations have a constant rate of change, right? So that's one important thing. Constant or unchanging rate of change. And again, there are many situations in the world that model a constant rate of change, and then we're talking about linear equations or lines. All right, and again, we'll get to this stuff later. Know that they exist, but also know more importantly that when I talk about a line, I'm not talking about something like that. That would be all considered a curve. Okay, for linear equations, again, we will graph them, but we will also write what the equations are. So you may see them visually like this, or you may see them symbolically, and both are important. So I just want to tell you about the three types of lines, the three major types of lines that you'll see. So linear equations come in three forms, or come in three common forms. Again, they can always mix it up and change it around, but these are the three common forms. The first one is y equals mx plus b. And this is the one that we've looked at most often so far. And if you recall from our discussion, this right here talks about where it hits the y-axis. So this is called the y-intercept. All right, and again, up on our pictures up here, the y-intercept is right here. It's where it crosses the y-axis. The y-intercept is right here. The y-intercept is right here. And again, in this weird case, there is no y-intercept. So it just talks about where it hits the y-axis. And it, again, well, let me go over here. This stands for the slope. And again, the slope is the rate of change. Right? And we've talked about slope being rise over run. Sometimes you'll see it as delta y over delta x. You would see that often in a science class. Delta is a Greek letter, and it just looks like a triangle, and it stands for the change in. All right, so this would say the change in y, the change in x. That's what rise is doing, seeing how far we change from the one y coordinate to another y coordinate. This run is telling us how far we change from one x coordinate to another x coordinate. So they mean the same thing, they're just written in a different way. And again, I'm going to say that this is, we read this as delta x. All right, you don't read it triangle x. You would either read it as delta x or the change in x. Either of those would be acceptable. Okay, this is the one that we've practiced with most often because this is super nice for when you're trying to graph something. It's very easy to graph, or a lot of times it's easy when you're trying to write an equation. So let me just give you an example here. Let's say we have y equals -1/2 x plus 1. Now we could always make an XY table and plot points. Again, that will always work. It may not be easy to do, but it will always work. But I'm not going to do this because if you remember, we talked about this before, that the first thing that we do is we're going to take this B point. And again, if you remember that B is where you begin, that might help. It doesn't stand for begin, but it is where we begin graphing. And so what we're going to do is we're going to go to 1 on the y-axis, because remember this is the y-intercept. So let me just put some marks on here. All right, so I'm going to begin at 1. And again, please don't think that that's really what it means, but in your mind, if you remember that that is where you should begin graphing, that might help. And then from there, we're going to use the slope to get other points. So this, again, in rise over run, rise saying go down 1 and run go over 2. So from here, I'm going to rise -1 or go down 1 and then run 2. And here's where I would put my next point. And then from here, I could do it again. I could rise -1, in other words, go down 1 and run 2. Here's my negative point, or my next point. I could also, if I ended up not having enough room to do that, I could always go backwards and say, well, if this was -1 over 2, I could just do backwards and go over. So here I'm going to run backwards 2 and run and rise up 1. And I could keep doing that to get more and more points if I needed to. But technically, as long as you do it correctly, you should only need 2 points. If you remember from our geometry, 2 points determine a line. So once we have those 2 points, we've got a line. Okay, so that is one form. The next form is standard form. Sorry, I'm going to go back to the other one because I forgot. We usually, the slang is y equals mx plus b form, but technically the name of this is slope-intercept form. And hopefully you're not wondering why that is the case. Hopefully it's pretty obvious that when you read this, you are given the slope and you're given the y-intercept, and so it's called slope-intercept form. Standard form, this is if you were just walking down the road and you happen to run into a line somewhere, this is probably what form it would be in. All right, ax plus by equals c. Now I'm just going to put our other form on here, our y equals mx plus b, and I want to just compare and contrast them. First of all, a, b, and c don't really stand for anything in here, like m stood for slope and b stood for y-intercept. There are no, you know, I can't translate this directly to the graph like I can with this. A is just the coefficient of the x term, B is the coefficient of the y term, C is the constant term. So I just want you to notice the differences here. All right, so first of all, y is by itself here, and everything else is on the other side, right? The x term and the constant are together on one side. Here, the x term and the y term are together on one side, and the constant is by itself. The other thing you should notice is that y has a coefficient of 1 here. There's never anything in front of this besides a 1. But here we're allowing the possibility that there would be a coefficient in front of y that's not 1. All right, now standard form is good for graphing, and there are two different ways that we can graph it. So let's say we take something like 3x minus 2y equals 6. All right, my guess is that if you saw something like this, your reaction would be, let me get it back to this form because I like this form, I'm comfortable with that form, and you can do that. All right, so if we did that, we're going to subtract 3x from both sides to get negative 2y equals negative 3x plus 6. All right, but again, remember, if we're trying to get it into that form, we cannot have a coefficient with the y. It has to be a 1. Well, so 1 is the coefficient. We can't have anything other than a 1 for the coefficient. So in order to get rid of that, I'm going to divide both sides by negative 2. When I do that, I have to divide every single term. Just don't just divide the x term by it. Make sure you get everything. So here, the negative 2's would cancel, and I'd have y equals negative 3 divided by negative 2 is going to give us a positive, but that's a fraction. We're just going to leave it as 3/2 x. And again, don't change into a decimal. Don't change it to a mixed number. We want rise over run. We want to see that as a fraction. So leave it as an improper fraction if that is the case. Please do not change it to a decimal. All right, and then 6 divided by negative 2 is going to give us negative 3. Right, there are other ways that you could do that. You could say, I don't like having a negative and having to divide by a negative, so you could decide to add 2y to both sides. So you would get 3y equals 6 plus 2y, and then just move the 6, so that would give me 3x minus 6 equals 2y, and then divide everything by 2. So here we would still get 3/2 x minus 3, and then I'm going to put the y over here. So if you would rather do that, you could do that. All right, and so then we would just say, oh, okay, I know how to graph that. I'm going to go down 3, because again, that's the y-intercept, it's the b, and that is where when we graph, we're going to begin. So I'm going to put a negative 3 there. Let me put some other marks here. So we're going to, this says rise 3, run 2. Rise 3, 1, 2, 3, run 2. And that would be our next point. And again, you could keep going if you want, if you had room. So I'm going to rise 1, 2, 3, run 2. And then, whoops, again, hopefully you're doing a better job than I am. And if you have graph paper, it's a little bit easier. Okay, so that would be our line. Now, some people will say, that's so much work. I don't want to have to change it into y equals mx plus b form first. And that is totally fine, because here's another way that we can do it. Now, remember when we plotted, we set up an XY chart or an XY table, and we usually would do things like -2, -1, 0, 1, 2, and we would pick some points for our X and we would get our Y values. All right, but again, what we've learned in geometry is you only need 2 points to determine a line. So let's be smart about it. Let's not pick all of those points. Let's pick 2 very specific points. And the 2 very specific points I'm going to pick are when X is 0, all right, that would be the y-intercept. So again, it's going to fall on the y-axis. And then the second point I'm going to pick is when y is 0, and that's going to give me the x-intercept. All right, so again, instead of picking all x values, this time I'm going to pick x equals 0 and figure out what the y-coordinate is, and y-coordinate 0 and figure out what the x is. And the reason I'm doing that is because zeros make things drop out. All right, so when we multiply by 0, they drop out. So the first time I'm going to go through and I'm going to let x equal 0. And when I do that, I get 3 times 0 minus 2y equals 6. That is gone. Sometimes I even just go up here and cover it up when I put the x in because I know it's going to disappear or drop out. And then all I'm left to solve is negative 2y equals 6. And again, that's the same thing that we have here. Negative 2y equals 6. When I divide both sides by negative 2, I get y equals negative 3. So that tells me that the y-coordinate is, the y-coordinate or the y-intercept here is negative 3. And again, we've already plotted that, so we know that. The next one we're going to do is the same thing, except now we're going to let y equal 0. So 3x minus 2 times 0 equals 6. Again, you could just cover that up right from the beginning and just solve there, 3x equals 6, but I'm going to write it and show you that you just get 3x equals 6. Divide both sides by 3 and I get x equals 2. And then when we go to plot, or put the points on there, 1, 2, 3, 1, 2. And that is exactly what we got right here. So again, we're being strategic. We're picking two very special points. This is the y-intercept, and this is the x-intercept. And again, we choose them because they make one of the terms in the equation drop out, and it makes it very easy to solve for the other one. All right, now let me go back up to this form. This is great for graphing, but if somebody asked you to write an equation, not so great. So we're going to make a little table to show what the equations are good for. But if somebody asked you to just write an equation like this, it would be a little bit tougher because, again, A, B, and C don't really have anything significant as they relate to the graph. Not at least directly. We could figure these things out, but just looking at it, they don't translate as nicely as in y equals mx plus b. Okay.